All right, we're going to be exploring loops, primarily for loops, while loops, and do while loops. Let's just go over some syntax and talk about some issues. Start with a for loop. So for bracket, parenthesis, int I equals 0. So this is a temporary variable I'm creating. That's why I'm declaring it int, and I'm naming it I, and I'm initializing it 0. You could use an existing variable in your code, but typically in a loop, we want a self-contained variable. The nice thing is that variable only exists inside this loop because it's created there. So then we create a condition to run. So this is a conditional statement, has to evaluate true or false. That will tell us whether or not the loop should run this time around. And we end with an iterator. Each of those three statements are separated by a semicolon. We open it up. So this says for a new integer called I that initializes to 0, as long as I is less than 10, go ahead and run the loop. And then when done running the loop, iterate. So this should print 0, iterate to 1, check. 1 is less than 10, good. Prints 1, iterates to 2, checks. Prints 2, 3, check, print, iterate, check, print, iterate, check, print. When it prints 9, it's going to come here, it's going to iterate to 10. It's going to jump up here, it's going to say 10 is not less than 10, that's false. So it will not run the code in the loop. It will instead jump to the end bracket and begin the rest of your program. So this should print 0 to 9. Your iterator is also very flexible. It can be a full mathematical equation. So you could do lab I equals I plus 3, for example, and have it jump by 3 each time. You can do a decrement, so I minus minus. Now that won't work in our current setup, so I'd have to change my initialization and my condition. So if I started at 10 and I say as long as it's bigger than 0, do a decrement. That should go backwards, just like that. Okay, so there's lots of ways that you can set these up in terms of this can be any Boolean statement, and this can be any increment, decrement, or full mathematical equation that affects your iterator. Okay, and then inside, obviously, you can have all kinds of code that can use the index or not use the index inside the loop. Cool. So for loops are great when you have fixed execution numbers. So you have a variable number or you know how many times you want to execute. Remember, this doesn't have to be 10. This could be a variable, right? Num x. And then up here, you could have num x 10, and that's fine. And then maybe that number comes from a user or it comes from a method or whatever. So there's some flexibility there, but typically for loops, their power comes in fixed execution. So when we know how many times we want it to execute. You can also do nested for loops as well. So I less than 0, or I equals 0, I less than 5, I plus plus. And then inside, I'll do for j equals 0, j less than 5, j plus plus. So I'm going to do system.out.print line, I equals plus I plus j equals plus j. We'll get to see those I and j values as it runs. So if we run that, what we'll see is I stays 0 for 5 executions as j cycles from 0 to 4. And then I stays 1 as j cycles. So the inner loop completes its full loop over and over and over and over for each time that the I value changes. So when I is 0, it's going to run this entire loop. Then when that loop fails, this ends, which means I iterates, and now the whole thing runs again. And then ends, I iterates, and the whole thing runs again. So you can create these neat little nested loops in here. All right, let's talk about while loops. So a while loop is great for variable execution. So a while loop syntax basically looks like this. While conditional. Basically, it just says, as long as this condition is true, keep running the code. I ran again. Now you can do funky stuff like this. Some programmers love the while true loop. So a while true loop will never end. Okay, it will just run forever and it'll crash your system eventually or your program eventually. It's not the ideal way to do things. Some people like this because then you just control with breaks. So I could have something like integer before my while loop. So I equals 0, And then I could do, say, if I is greater than 10, break, else system.out.println I, and then I plus. So we are manually doing the iteration now, but I could do something like this. This is going to run essentially the same way. It's going to go 0 all the way up to 10. If I run that, 0 all the way up to 10. So this is just me taking manual control of it using a break statement. Break will break out of the kind of the closest loop structure. So it's great for things like that. But while loops typically are going to have something in it like while I is less than 11. So forget the if else structure, forget the breaks, right? We can just take this. It's great. The only difference between this and the for loop is that I'm responsible for manually iterating, and I'm responsible for manually declaring and initializing the variable before the loop starts. So run exactly like the for loops from before, 0 to 10. So there's all that control that we can do with a while. The thing with a while loop that some people don't like is that the while loop is going to check the condition at the very beginning before it runs any of the code. So if you ever wanted the code to run once and then have a condition to fail, so just for example, let's say this was a user input situation and we wanted to print something and give them an option to enter a value. And if they didn't enter a value we liked, we reprint the statement. So something like, let's create a scanner. I gotta import it. Okay. And then let's say we're going to do a string user val, null string for now. So while user val dot equals q, and we'll put a not in front of that. So as long as the user has not entered q, then we want to print something like input value, and we'll make that a print statement. And then we'll grab our user val equals kv.next line, and then system line. So essentially this code, unless they enter a queue, is just going to keep running ever, which may or may not be what we want. And then if they enter a queue, it should quit. So the thing about this is because the user val is starting blank, that's fine. It should let it run. So let's just run that and just test it out. Oh, what did I get? I might have to initialize that to a null string. Let's run it now. Okay. So input value K, A, B, C, and Q, and it quits. So that's one way we can use a while loop. But the other way is sometimes we want to print this stuff out and then have it check only after one execution. So to do that, we can use a do while loop, which basically just, it looks like this. So it's essentially the exact same thing as a while loop. The only difference is it will run the code in the loop one time no matter what before it checks the condition. Then it will check the condition. And then if the condition fails, it won't run it again. So it's exactly like a while loop, just allows for the code to execute once automatically without checking a condition. And then we'll check the condition at the end of that first execution and at the end of each subsequent execution. So sometimes that works better. It's literally the only difference is about that first execution. Everything after the first execution doesn't really matter. It's all going to run the same. So that's our for loops, our while loops, and our do while loops and the structure for them. And you can nest any number of these loops together. They all serve different purposes and they all have different benefits. Yeah, it's important to have that structure because we're going to use loops a lot when we're looping through strings, when we're looping through arrays, when we're looping through array lists. Good luck. Talk to you soon.